Hi everyone, my name is Nam. Today I'm gonna help you to solve the problem 46 of chapter 29. So here is the problem. A very long rectangular loop of wire can slide without friction on a horizontal surface. Initially, the loop has part of its area in the region of uniform magnetic field that has magnitude is 2.9 t and is perpendicular to the plane of the loop. The loop has dimension 4 cm by 60 cm and the mass is 24 grams and resistance is 5 times 10 to the power of negative 3 ohm. The loop is initially at rest, then a constant force is 0.180 Newton is applied to the loop to pull it out of the field. A. What is the acceleration of the loop when the velocity is 3 cm per second? B. What are the loop's terminal speed and acceleration when the loop is moving at terminal speed? And C. What is the acceleration of the loop when it is completely out of the magnetic field? Okay, so let me redraw the situation, the graph, to help you easier to visualize. So we have a magnetic field B in this small area and a rectangular loop has a width is 4 centimeter over here. I'm sorry, let me draw it over here. This area, this length is 4 centimeter and this length is 60 centimeter. The loop is applied force from the left to the right. Let me symbol the force is external force from the left to the right with a velocity v. Okay, and the part A is what is the acceleration of the loop when the velocity is 3 centimeter per second. So in order to do this part, we need three formulas. The first one is the motional EMF. Motional EMF. We have velocity, we have magnetic field, and we have the length. The second formula is the Ohm's law. We have the current will be equal to the voltage divided to resistor. And the third one is magnetic force. The current, the length of the loop, magnetic field, and the sine of the angle between the magnetic field and the length. In this case, since the length in this area is perpendicular to the magnetic field, it means that we have ILB sine 90, and we know that sine 90 is 1. So we have I, L, and B. Now, we combine three formulas together to find a magnetic force of the loop. Magnetic force exerted on the loop. So we substitute 1, 2 into 3. So we have F magnetic force equal I the current L B, and the I equal the voltage divided resistor times L times B, and the voltage now replaced by the emotional EMF with velocity, magnetic field, and length. I'm sorry, this one is the capital L. And now we combine and simplify the formula. We have V L square, B square, and R. And now we have to use the fourth formula, that is the Newton's second law. It states that the total force exerted on the loop will be equal m A. A is the velocity, which is also the A is the acceleration, which is also the object that we are going to find. Now assume that the positive direction would be from left to right. So in this situation, we will have the induced EMF move counterclockwise along the loop. The reason is, for example, we choose the normal vector of the area of the loop is point into the page, and then we have a positive flux. But when the loop is moved out of the magnetic field region, it means that the flux decreases, so it will create a induced EMF, and move counterclockwise. So if we use the right hand rule, we will find out that the magnetic force will be from the right to the left, like this. And now you can see that the external force is in positive direction, and the magnetic force is in negative direction, so it must be minus. Equal MA. Now we will replace magnetic force by this formula. And now we have external force minus the formula that we just found above equal MA. And now we divide the left hand side to M. We will have A equal 1 over M external force minus magnetic force. Now in this part, we just plug the number into it. So according to the problem, we have the mass is 24 grams, but we have to convert to kilogram. It means that I have to minus 10 to the power negative 3 kilogram. External force is 0.18 Newton minus the velocity is 3 centimeter per second, but we have to convert to meter. Means that 3 10 negative 2 meter per second. And then the L is 4 centimeter. We also have to convert to meter. Don't forget the square. And the magnetic field is 2.90 T square. And the resistor is 5 and 10 to the power to the negative 3 ohm. And then we will find out the acceleration. So the result would be 4.14 meter per second square. And this is the part A. Okay, so the part B is what are the loop terminal speed? B. What is the terminal speed? And acceleration when the loop is moving at terminal speed. Acceleration. In this case, the terminal speed, it means that the terminal reaches a constant values. When the velocity reaches the constant value, it means that the acceleration would be 0. So terminal speed it means acceleration will become 0. So like we have the formula, the Newton law, the second Newton law. We have external minus magnetic force equal ma, and now a becomes 0, so we will come with the formula at F. The external force will be equal to magnetic force. Now we continue to substitute the formula of magnetic force, and then we will find out the velocity. We have the external force is 1.8 Newton equal to VL square B square R. Now we will take out V and we simplify the equation, and then we will have equation like this. And now we continue plug the number into the formula. Sorry. Here is 4 times 10 to the power -2 square, and b is 2.9 t square. And then we have the velocity is 0.0669 meter per second. And then the part C is what is the acceleration of the loop when it is completely out of the magnetic field. So when the loop is out of magnetic field, it means that there is no induced current, no induced current. It means that no magnetic force. And according to the Newton's second law, okay, let me write fast. The Newton's second law, it means that we have the total force will become ma, and external minus magnetic field will go ma. But in this situation, the magnetic force is equal to 0. It means that we have only external force applied on the loop equal ma. And then the acceleration would be equal external force divide the mass. That's why it's very easy. So we just plug the number into it. Remember, you have to convert gram to kilogram. And then we have 7.5 meter per second square. So this is the end of the problem 46 of chapter 29, and thank you for listening. Have a good night.